grouping, and the second factoring method, like I said, we will talk about, is called grouping. And we use grouping when we have 4 terms, typically. And the thing about grouping is it relies heavily on our previous notes, which was factoring a greatest common factor. So we need to remember to look for our greatest common factors when we use this grouping technique. So as we take a look at our first example, x cubed plus 2x squared plus 5x plus 10 has 4 terms in it. X cubed is a term, 2x squared is a term, 5x is a term, 10 is a term. And what we're going to do is we're going to break this group of 4 up into x cubed plus 2x squared. We're going to make that a group. And then we're going to make 5x plus 10 a group. So we split that. And what we're now going to do is we're going to look, do we have a greatest common factor in our first group? Well, between x cubed and x squared, recall from earlier notes that we take out the smallest exponent. It's going to be x squared. That's all that we have in terms of our greatest common factor. And what we have now is, we had 3 x's, we took out 2 of them, which means that there's 1 x remaining. 2x squared divided by x squared is simply 2. We had 2 x's, we took them both out, so all that we have left is 2. We're going to go through that same process in our second group. What's in common between 5x and 10? Our greatest common factor. It's going to be 5. And then 5x divided by 5 is x. 10 divided by 5 is 2. So we used our skills of greatest common factor here to get to this point, but we want to finish here. And what happens now is we're going to look for the greatest common factor one more time from each group. And what we see from our first group is that we have in x plus 2, and in our second group we have in x plus 2. That's our GCF of our group. So we write down x plus 2. We only write it down once. It's coming from both groups. Then the rest of our factoring process is that we still have an x squared, and we still have a plus 5. And there's our factored version of that problem. Again, relies heavily on greatest common factor. I'm going to do one more thing to this problem, but I don't think that you should write it down. I just want to show you here that x times x squared is x cubed. Again, I don't think that you should write this down. X times 5 is 5x. 2 times x squared is 2x squared. And 2 times 5 is 10. It's a different order, but if you look back at the problem, when we FOILed our answer, here's x cubed. Here's the 2x squared, 5x, and 10. We come up with the same problem. It's in a little bit different order, but we still came up with the problem. So if you feel the need to check on a test, on a quiz, on your homework, all that you would have to do is FOIL your answer, and you should come up with the original problem. It might be in a different order, but it still should be the same problem. But what we are going to focus on today is how do we factor these problems. And once again, we have 1, 2, 3, 4 terms. 5x cubed is a term. 20x squared is a term. 3x is a term. 12 is a term. 4 terms typically indicates that we're going to factor by grouping. With a quick glance, I look to see, do we have a greatest common factor in this entire problem, and I don't see one. But if we split this problem up into 2 groups of 2, then we can use our greatest common factor skills. As we look at the first problem, let's do the numbers first. Do we have anything in common between 5 and 20? You can show me on your fingers, it's 5. Between x cubed and x squared, we're taking the smallest exponent. And now we're going to figure out what's still in our parentheses. Well, 5x cubed divided by 5x squared, 5 divided by 5 is 1. We had 3 x's, we took out 2, so we're left with 1x. 20x squared divided by 5x squared is 4. Notice, we had 2 x's, we took out 2 x's, we don't have any left inside our parentheses. We factored the GCF in our first group, now let's factor our GCF in the second group. What's in common between 3 and 12? Jordan? It's 3. 3x divided by 3 is x. 12 divided by 3 is 4. And now we can finish the problem. What we're looking at now is the greatest common factor from both groups. Well, we have an x minus 4 in the first group. We have an x minus 4 in the second group. So we're going to write that x minus 4 down one time. And then we're going to write what's still there. 5x squared plus 3. The 5x squared out in front of the parentheses, the 3 out in front of the parentheses. We could FOIL and come up with our original problem if we needed to. Problem number 3. Always looking at a glance to see if we have a greatest common factor overall. Hayden, take the pass sign out. So when we look at this one, we do not see greatest common factor overall. But what we do see is that we can break this into 2 groups here and look for the greatest common factor there. Well, in that first group, we don't have any numbers that are greatest common factors, but we do have variable that is greatest common factor. And just as an aside here, it's not my favorite thing, but x cubed is x times x times x, and then this is 2 times x times x. That's always a technique that we can fall back on if we need to. And what happens is we can see that our greatest common factor here then will be x squared. It's the smallest exponent on the variable. And when we look at what still remains here, we had 3 x's, we took out 2, so we have 1 left. 1 that didn't get circled. Over here we had 2 x's, we took them both out. The only thing that didn't get circled was the 2. 2x squared divided by x squared is 2. Be a little bit careful here. There's a minus sign in between. But we still want to go through the process of finding our greatest common factor. And between 3 and 6, it is 3. And what remains in the parentheses? 3x divided by 3 is x. Negative 6 divided by negative 3 is positive 2. Watch out with that negative. Negative 6 divided by negative 3 is positive 2. But now, what happens is, when we look, we've got x plus 2 from the first group, x plus 2 from the second group. We're only going to write that down once, and then we're left with x squared minus 3. Again, when we start these problems, we need to notice that there are 4 terms. When we see 4 terms, that should signal to us that we need to group. When we group on this particular problem, we need to at least overall glance and go, do we have a greatest common factor in everything? And we don't have a greatest common factor in everything, but when we do split them up into 2 groups, we will be able to find a greatest common factor in the first group, and we'll be able to find a greatest common factor in the second group. So as we look here at our first group, between 15 and 25, what's the biggest number that goes into both of those? 5. Can you do the x's as well, Tiffany? 5x squared. We're taking the smallest exponent between x cubed and x squared. When we factor that out, what's going to happen to look at our remaining values in our parentheses, we're going to divide. 15 divided by 5 is 3. X cubed divided by x squared. We had 3 x's, we took out 2, so there's 1 left. 25x squared divided by 5x squared is simply 5. We had 2 x's, we took them both out, so we're not going to write them down again. Now watch out, because there's a minus sign in between. But what's the greatest common factor between 18 and 30? It's actually 6. So if you thought 3, things aren't going to work out. So if it didn't work out, go back and see if there's anything else. But if we take out the 6, 18x divided by 6 is 3x. It's positive 30 divided by negative 6 will give us negative 5. Watch out for the signs there. And typically what happens is what we get in the first parentheses, we want to get in the second parentheses. So see if we can make it work. And now what we see, from our first group, we have a 3x minus 5. From our second group, we have a 3x minus 5. So that's in common in both groups. You only write it down once. And then what we're left with is our single value, 5x squared minus 6, another single value. Greatest common factor is really an integral theme within our factoring by grouping method that we're looking at today. And as we take a quick look at problem number 5, we should always, on all of our factoring problems, look first to decide, do we have a greatest common factor? Well, when we look at this problem, we've got an 18 and a 9 and an 18 and a 9, and I know I didn't say signs, but there actually is an overall greatest common factor on this problem that didn't exist on our first 4 examples. And if you look closely, what happens is that 18 and 9 and 18 and 9 all have a 9 in them. So one of our greatest common factors is a 9. And when we factor that out, 18x cubed divided by 9 is 2x cubed. 9x squared divided by 9 is 1x squared. 18x divided by 9 is 2x. And 9 divided by 9 is 1. So we have an overall GCF in this problem. But we still have 4 terms, and we need to look and see, can we factor by grouping in this particular case? So let's break it up into our 2 groups. And I know we have the 9. I'm going to ignore the 9 for a couple minutes. We'll put it back in here shortly. But in our first group, do we have a greatest common factor? Between x cubed and x squared, it's our smallest exponent. It's x squared. And when we factor that out, 2x cubed divided by x squared is 2x. We had 3 x's. We took out 2 of them, so we have 1. X squared divided by x squared is 1. We took out all of the x's. So over here in our next group, we don't have a GCF, but we do want to write it as a group. And when we write it as a group, what's the number in front of the parentheses, also known as a coefficient? Well, it happens to be a 1. Now that we've grouped our values, let's go back and look. Do we have anything in common from both groups? Well, we have a 2x minus 1. We only write that down once. It's in common from both of the groups. Then we go back and look at our single values, sometimes known as a monomial. X squared is a single, and the plus 1 is a single. The last thing not to forget is that we started this problem by taking out a 9. Now we have a completely factored version of this. Finally, problem number 6. We look, quick glance, we don't have a greatest common factor. And if you're writing in pen, don't write down yet, because look at what happens if we break these into 2 groups here. What's our greatest common factor in the first group? Well, we look at that and we have nothing. That's the greatest common factor in the first group. In our second group, we have an x, but that's not going to help us very much. So what's going to happen here on this problem is that we need to rearrange this so that we actually can group. It's called descending order when we rearrange. And we start, first of all, with the 3x cubed. I started with that value because x cubed, 3 is the highest exponent on the x. Then we're going to descend, which means that we're going to get smaller. And so the next term is going to be minus 15x squared, because x squared is smaller than x cubed. We're going to descend again with the plus 2xy, because the exponent on this x will be 1. So we've got 3, 2, 1, which means that our last term is going to be the minus 10y, because there's 0 x's on that one. And now that we've rearranged this problem, we have at least a good chance of being able to factor by grouping. So we look at this one, and between 3 and 15, what's in common? What's the biggest number that goes into both? 3. What about the exponents on the x? The x squared. We take the smallest exponent. The biggest number, the smallest exponent. Well, 3x cubed divided by 3x squared is 1x. By the way, we had 3 x's. We took out 2 of them, which means that we have 1 left. 15x squared divided by 3x squared is 5. We had 2 x's. We took them both out. Over here in our next group, between 2 and 10, our GCF is a 2. Between x, y, and y, our GCF is a y. And when we factor this out, then 2xy divided by 2y is x. 10y divided by 2y is 5. We had 1y, we took it completely out. So to finish, what we're looking for is, do we have anything the same in both? Well, we have an x minus 5 here and an x minus 5 there. That's our GCF from each group. And then we'll write down our singles, the 3x squared plus 2y. One final comment. It doesn't matter to me if you write down 3x squared plus 2y first, and then the x minus 5 second.